Hello students, today we will learn about bioorganic and biophysical chemistry and biochemistry tools. The fundamental principles of bioorganic and physical chemistry besides the common tools employed in biochemistry. Now let's know about the introduction to bioorganic chemistry. As life comes from previous life, it was believed for a long that the carbon compounds of organism arose from life only. This is referred to as vital force theory. Friedrich Holler in 1825 first discovered that urea, that is NH2CO NH2. The organic compound could be prepared by heating ammonium cyanide, that is NH4NCO, in the laboratory. Thereafter, thousands and thousands of organic compounds have been synthesized outside the living system. Organic chemistry broadly deals with the chemistry of carbon compounds regardless of their origin. Biochemistry, however, is concerned with the carbon chemistry of life only. The general principle of organic chemistry provides strong foundations of understanding biochemistry. However, biochemistry exclusively deals with the reactions that occur in the living system in aqueous medium. Now let's know about the most common organic compounds found in living system. The organic compounds, namely carbohydrates, lipids, proteins, nucleic acids and vitamins are the most common organic compounds of life. Now let's know about common functional groups in biochemistry. Most of the physical and chemical properties of organic compounds are determined by their functional groups. Biomolecules possess certain functional groups which are their reactive centers. Now let's know about the common ring structures in biochemistry. There are many homocyclic and heterocyclic rings commonly encountered in biomolecules. So, homocyclic rings. Let's know about homocyclic rings. Phenyl ring derived from benzene is found in several biomolecules like phenylalanine, tyrosine, catecholamines, etc. Phenanthrene and cyclopentane from the backbone of steroids, cholesterol and aldosterone. Coenzyme Q is an example of benzoquinone, while vitamin K is a naphthoquinone. Now, let's know about heterocyclic rings. Furan is the ring structure found in pentoses. Pyrrole is the basic unit of porphyrins found in many biomolecules, that is heme, while pyrrolidine is the ring present in the amino acid proline. Thiophene ring is a part of the vitamin biotin. The amino acid histine contains imidazole. Now let's know about pyran ring. Pyran structure is found in hexoses. Pyridine nucleus is a part of the vitamins niacin and pyridoxine. Pyrimidine, that is cytosine and thiamine, and purine, that is adenine and guanine, are the constituents of nucleotides and nucleic acids. Purine and indole are examples of fused heterocyclic rings. Now let's know about isomerism. The compound possessing identical molecular formula but different structures are referred to as isomers. The phenomenon of existence of isomers is called isomerism. In Greek word isos, that means equal, meros means part. Isomers differ from each other in physical and chemical properties. Isomerization Isomerism is a partly responsible for the existence of a large number of organic molecules. Let's consider the molecular formula C2H6O. There are two important isomers of this, that is ethyl alcohol and diethyl ether. Isomerism is broadly divided into two categories, that is structural isomerism and stereoisomerism. Let's know about first structural isomerism. The difference in the arrangement of the atoms in the molecule, that is molecular framework, is responsible for the structural isomerism. This may be due to variation in carbon chains, carbon isomerism, or difference in the position of functional groups, that is position isomerism, or difference in both molecular chain and functional group, that is functional isomerism. Structural isomerism as such is more common in general organic molecules. Now let's know about tautomerism. What do we mean by tautomerism? Tautomerism is a type of structural isomerism occurs due to the migration of an atom or group from one position to the other. Example, purines and pyrimidines. Now let's know about stereoisomerism. Stereo means space and isomerism means occupying. Okay, space occupying. Is stereoisomerism is perhaps more relevant and important to biomolecules. The differential space arrangement of atoms or groups in molecules gives rise to stereoisomerism. Thus, stereoisomers have the same structural formula but differ in their special arguments. Stereoisomerism. Let's know isomerism types. There are two types of stereoisomerism. One is geometric and another is optical. Geometric isomerism and second is optical isomerism. So let's start with geometric isomerism. This geometric isomerism is also called as cis-trans isomerism, is exhibited by certain molecules possessing double bonds. Geometrical isomerism is due to restriction of freedom of rotation of groups around a carbon-carbon double bond. Malic acid and fumaric acid are the classical example of cis-trans isomerism. When similar groups lie in the same site, it is called cis-isomerism. On the other hand, when similar groups lie on the opposite sides, it is referred to as trans-isomerism. In Latin word, trans means across. As is observed from this structure, malic acid is a cis form while fumaric acid is a trans form. Geometric isomerism is also observed in steroids and porphyrins. In cis-trans isomers differ in physical and chemical properties. Let's know about optical isomerism. Optical isomers or enantiomers occur due to the presence of an asymmetric carbon, a chiral carbon. Optical isomers differ from each other in their optical activity to rotate the plane of polarized light. Now let's know about what is an asymmetric carbon. An object is said to be symmetrical if it can be divided into equal halves. Example, a ball. Objects which cannot be divided into equal halves are asymmetric. Example, hand. An asymmetric object cannot coincide with its mirror image. For instance, left hand is the mirror image of right hand, and these two can never be superimposed. In contrast, a symmetrical object like a ball superimposes its image. A carbon is said to be chiral in Greek. Greek means hand, or asymmetric, when it is attached to four different groups, their mirror images do not superimpose with each other. The number of possible optical isomers of a molecule depends upon the specific number of chiral carbon. It is given by 2 to the power n. And now let's know about the what is optical activity. The ordinary light propagated in all directions. The ordinary light propagates in all directions. However, on passing ordinary light through a nickel prism, the plane of polarized light vibrates in one direction only. Certain organic compounds, that is optical isomers, which are said to exhibit optical activity, rotates the plane of polarized light either to the left or in the right. The term laboratory indicated by one or minus sign is used for the substances which rotate the plane of polarized light to the left. On the other hand, the term dextrorotatory, that is that is indicated by D or plus sign, is used for the substances rotating the plane of polarized light to right. The term racemic mixture represents equal concentration of D and L forms which cannot rotate in the plane of polarized light. Now let's know about the configuration of chiral molecules. While representing the configuration of chiral molecules, the configuration of glyceraldehyde is taken as a reference standard. It must, however, be remembered that D and L do not represent the direction of rotation of plane of polarized light. Now, let's know about existence of chiral biomolecules. As you know, you can never come across anybody who is your mirror image. The same is true with biomolecules. Only one type of molecules, that is D or L, are found in the living system. Thus, the naturally occurring amino acids are of L type while the carbohydrates are of D type. Now, let's know about the overview of biochemical chemistry. The general laws and principles of chemistry and physics are applicable to biochemistry as well. It is therefore worthwhile to have a brief understanding of some of the basic chemical and physical properties principles that have direct relevance to life. It must, however, be remembered that all these aspects are quite unrelated to each other. Now, let's know about acids and bases. According to Laurie and Bronsted, the two scientists, an acid is defined as a substance that gives off protons, while a base is a substance that accepts protons. Thus, an acid is a proton, that is H plus donor, and a base is a proton acceptor. Now, let's know about alkalis. The metallic hydroxides such as NaOH, sodium hydroxide, and potassium hydroxide, that is KOH, are commonly referred to as alkalis. These compounds do not directly satisfy the criteria of bases. However, they dissociate to form metallic ion and OH minus ion. The latter, being a base, accepts H plus ions. Now let's know about ampholytes. The substances which can function both as acids and bases are referred to as ampholytes. Water is the best example for ampholytes. Now, let's know about hydrogen ion concentration, pH. The acidic or base nature of a solution is measured by H plus ion concentration. The strength of H plus ions in the biological fluids is exceedingly low. For this reason, the conventional units such as molecules per liter or gram per liter, moles per liter or gram per liter are not commonly used to express H plus ion concentration. Now, So now next the scientist named Sorenson in 1909 introduced the term pH to express H plus ion concentration. pH is defined as the negative logarithm of H plus ion concentration, that is pH equals to minus log H plus. Now let's know about buffers. The pH of a given solution can be easily altered by the addition of acids or bases. Buffers are defined as the solution which resists a change in pH by the addition of small amount of acids or bases. A buffer usually consists of a weak acid and its salt, or a weak base and its salt. Several buffers can be prepared in the laboratory. Nature has provided many buffers in the living system. Now let's know about the mechanism of buffer actions. Let us consider the buffer pair of acetic acid and the sodium acetate. Acetic acid being a weak acid feebly ionizes. On the other hand, sodium acetate ionizes to a large extent C3, CH3COOH, CH3COO minus plus H plus. Another reaction is CH3COO Na reverse reaction CH3COO minus plus Na plus. When an acid says, let's say HCl is added, the acetate ion of the buffer bind with H plus ions, that is of HCl, to form acetic acid, which is weakly ionizing. Therefore, the pH change due to acid is resisted by the buffer. H plus and CH3COO minus gives rise to CH3COOH. When a base, let's say NaOH, sodium hydroxide, is added with the H plus ions of the buffer, that is acetic acid, combines with OH minus ion to form water, which is weakly dissociated. Thus the pH change due to base addition is also prevented by the buffer. OH minus plus H plus gives rise to H2O. Now let's know about buffering capacity. The efficiency of a buffer in maintaining a constant pH on the addition of acid or base is referred to as buffering capacity. It mostly depends on the concentration of the buffer components. Now let's know about the solution. Solution may be regarded as mixtures of substances. In general, a solution is composed of two parts, solute and solvent. The substance that is dissolved in solute and medium that dissolves the solute is referred to as a solvent. The particle size of a solute in solution is smaller than 1 nanometer. The relative concentration of the substances in a solution can be measured by several ways. Now let's know about percentage concentration. This represents parts per 100. The most frequently used is weight per volume, W by V. Example, 9% saline, that means 9 gram divided by 100 ml solution. So now let's know about the ppm, that is parts per million. This refers to the number of parts of the substance in the million parts of the solution. Thus, 10 ppm chlorine means 10 microgram of chlorine in 1 gram of water. Now, let's know about molarity, that is in short M. It is defined as the number of moles of solution per liter solution. NaCl has a molecular weight of 58.5. To get 1 molar, that is 1 m, or 1 mole solution of NaCl, 1 gram molecular weight, that is 58.5 gram of it should be dissolved in the solvent, that is H2O, to make a final total volume of 1 liter. For smaller concentration, millimole and micromole are used. Now let's know about molality. It represents the number of moles of solute per 1000 gram of solvent. 1 molar solution can be prepared by dissolving 1 mole of solute in 1000 gram of solvent. Now let's know about normality. Molarity is based on molecular weight while normality is based on the equivalent weight. 1 gram equivalent weight of an element or a compound represents its capacity to combine or replace 1 mole of hydrogen. Now let's know about the colloidal state. Thomas Graham in 1861, regarded as the father of colloidal chemistry, divided substances into two classes, that is crystalloids and colloids. Crystalloids are the substances which in solution can freely pass through parchment membrane. Example: sugar, urea, NaCl. Colloids, that is in glue-like, on other hands, are the substances that are retained by parchment membrane. Example: gum, gelatin, albumin. This classification of Graham is no longer tenable since any substance can be converted into a colloid by suitable means. For instance, sodium chloride is in benzene forms a colloid. Now let's know about colloidal states. Colloidal state. As such, there are no group of substances as colloids. Rather, substances can exist in the form of colloidal state or colloidal system. Now, colloidal state is characterized by the particle size of 1 to 100 nanometer. When the particle size is greater than 1 nanometer, it is in true solution. For the particle size smaller than 100 nanometer, the matter exists as a visible participant. Thus, the colloidal state is an intermediate between true solution and precipitate. Now, let's know about phase of colloids. Colloidal state is heterogeneous with two phases. Now, let's know about the two phases. One phase is dispersed phase, another is dispersion medium. Dispersed phase, that is internal phase, which constitutes the colloidal particles, and the second is dispersion medium, that is external phase, which refers to the medium in which the colloidal particles are suspended. Now let's know about classification of colloids. Based on the affinity of dispersion medium with the dispersed phase, colloids are classified as lymphobic and lyophilic. One is lyophobic and another is lyophilic colloids. Let's know about lyophobic. Lyophobic means solvent heating. These colloids do not have any attraction towards dispersion medium. When water is used as dispersion medium, the colloids are referred to as hydrophobic. Second is lyophilic. Lyophilic means solvent loving. These colloids have distinct affinity towards dispersion medium. The term hydrophilic is used for the colloids when water is the dispersion medium. Now let's know about the biological importance of colloids. Biological fluids. First is biological fluids as colloids. These include blood, milk and cerebrospinal fluid. Second is biological compounds as a colloidal particles. The complex molecules of life, the high molecular weight proteins, complex lipids and polysaccharides exist in colloidal state. Third is fat digestion and absorption. The formation of emulsions facilitating by the emulsifying agents bile salts promotes fat digestion and absorption in the intestinal tract. Fourth is formation of urine. The filtration of urine is based on the principle of dialysis. Next is diffusion. The molecules in liquids or gases are in continuous motion. Diffusion may be regarded as the movement of solute molecules from a higher concentration to a lower concentration. Now, diffusion is more rapid in gases like gases than in liquid. The smaller particles diffuse faster in than the larger ones. The greater the temperature, the higher is the rate of diffusion. Now let's know about the applications of diffusion. Exchange of oxygen and carbon dioxide in lungs and in tissues occurs through diffusion. Next point is certain nutrients are absorbed by diffusion in the gastrointestinal tracts. Example pentoges, minerals, water soluble vitamins. Third is passage of the waste products, namely ammonia, in the renal tubules occurs due to diffusion. Next point is osmosis. Osmosis means push, refers to the movement of the solvent, most frequently water, through a semi-permeable membrane. The flow of the solvent occurs from a solution of low concentration to a solution of high concentration when both are separated by a semi-permeable membrane. Now let's know about osmotic pressure. Osmotic pressure may be defined as the excess pressure that must be applied to a solution to prevent the passage of solvent into the solution when both are separated by a semi-permeable membrane. The solutions that exert the same osmotic pressure are said to be isoosmotic. The term isotonic is used when a cell in direct contact with an isoosmotic solution, that is 0.9% NaCl, when which does not change the cell volume that and thus the cell tone is maintained. A solution with relatively greater osmotic pressure is referred to as hypotonic. On the other hand, a solution with relatively low pressure is hypotonic. Now let's know about units of osmotic pressure. Osmotic pressure of biological fluids is frequently expressed as milliomoles. The osmotic pressure of plasma of human blood is 280 to 300 millisimoles per liter. Now let's know about applications of osmosis. First is fluid balance and blood volume. The fluid balance of the different compartments of the body is maintained due to osmosis. Now let's know about red blood cells and fragility. When the RBC are kept in hypotonic solution, that is say 0.4% NaCl, the cells bulge due to entry of water, which often causes rupture of plasma membrane of RBC, that is homolysis. Three is transfusion. That means isotonic solution of NaCl, sodium chloride, or glucose, that is 5%, NaCl 0.9%, or glucose 5%, or a suitable combination of these two are commonly used in transfusion and in the hospitals for the treatment of dehydration, burns, etc. Fourth is action of purgatives. The mechanism of action of purgatives is mainly due to osmotic phenomenon. For instance, Epsom, that is MgSO4 7H2O, or Gluabars Na2SO4 10H2O salts withdraw water from the body, besides preventing the intestinal water absorption. Next point is 5, that is edema due to hypoalbuminemia. Disorders such as kwashiorkor and glomerulonephritis are associated with lowered plasma albumin concentration and edema. Edema is caused by reduced oncotic pressure of plasma, leading to the accumulation of excess fluid in tissue spaces. Now let's know about viscosity. Liquid or fluid has a tendency to flow, which is referred to as fluidity. The term viscosity may be defined as the internal resistance offered by a liquid or a gas to flow. The property of viscosity is due to frictional forces between the layer while their movement occurs. Let's know about viscosity. Liquid or fluid has a tendency to flow, which is referred to as fluidity. The term viscosity may be defined as the internal resistance offered by a liquid or a gas to flow. The property of viscosity is due to fractional forces between the layers while their movement occurs. Viscosity of colloidal solutions, particularly lyophilic colloids, is generally higher than true solutions. Units of viscosity. Let's know about the units of viscosity. The unit of viscosity is poised after the scientist Poiseuille, who first systematically studied the flow of liquids. The pose represents dynes or centimeter square. Dynes per centimeter square. Now let's know about the applications of viscosity. Viscosity of blood. Blood is about 4 times more viscosity than water. The viscosity of blood is mainly attributed to suspended blood cells and colloidal plasma proteins. Second is viscosity change in muscle. Excitation of the muscle is associated with increase in the viscosity of the muscle fibers. This delays the change in the tension of the contracting muscle. Now let's know about the surface tension. A molecule in the interior of a liquid is attracted by other molecules in all directions. In contrast, a molecule on the surface is attracted only downward and sideways and not upwards. Due to this, the surface layer behaves like a stressed film. Now let's know about applications of surface tension. First is digestion and absorption of fat. Bile salts reduce the surface tension. They act as detergents and cause emulsification of fat, thereby allowing the formation of minute particles for the effective digestion and absorption. Next is surfactants and lung function. The low surface tension of the alveoli keep them apart and allows an efficient exchange of gases in lungs. In fact, certain surfactants, predominantly dipalmitoyl phosphatidylcholine, that is dipalmitoyl lecithin, are responsible for maintaining low surface tension in the alveoli. Surfactant deficiency causes respiratory distress syndrome in the infants. Now let's know about adsorption. Adsorption is a surface phenomenon. It is the process of accumulation of a substance, that is adsorbate, on the surface of another substance, that is adsorbent. Adsorption differs from adsorption as the latter involves the diffusion into the interior of the material. Now let's know about the applications of adsorption. Formation. First point is formation of enzyme substrate complex. For the catalysis to occur in biological system, formation of enzyme substrate complex is a prerequisite. This happens by adsorption of substrate on the enzyme. Second point is action of drugs and poisons. On adsorption at the cell surface, drugs and poisons exerts their action. Third point is adsorption in analytical biochemistry. The principle the principle of adsorption is widely employed in the chromatography technique for the separation and purification of compound like enzymes, immunoglobulins. Now let's know about isotopes. Isotopes are defined as the elements with same atomic number but different atomic weight. They possess the same number of protons, differ in the neutrons in their nuclei. Therefore, isotopes, iso means equal and top means place, equal place, occupy the same place in the periodic table. The chemical properties of different isotopes of a particular element are identical. Isotopes are of two types, stable and unstable. The latter are more commonly referred to as radioactive isotopes and they are of particular interest to biochemists. Now let's know about stable isotopes. They are naturally occurring and do not emit radiations. Non-radioactive example deuterium, heavy hydrogen, H2, carbon 13, nitrogen 15 and oxygen 18. Stable isotopes can be identified and quantitated by mass spectrometry or nuclear magnetic resonance NMR. They are less frequently used in biochemical investigations. Now let's know about radioactive isotopes. The atomic nucleus of radioactive isotopes is unstable and therefore undergoes decay. The radioactive decay gives rise to one of the three ionizing radiation. First is alpha rays, beta rays, and gamma rays. Alpha rays, that means an alpha particle possessing two protons, that is helium nuclei. Beta rays, that is due to the emission of electrons. The three is gamma rays due to emission of high energy photons, and the beta and gamma emitting radioisotopes are employed in biochemical research. Now let's know about applications of radioisotopes in biochemistry. Radioactive isotopes have become indispensable tool of biochemistry. They are conveniently used as tracers in biochemical research since the chemical properties of different isotopes of a particular element are identical. Therefore, the living cells cannot distinguish the radioactive isotope from a normal atom. A few important applications of radioisotopes now list we will discuss. First is by the use of isotope tracers, the metabolic origin of complex molecules such as heme, cholesterol, purines, and phospholipids can be determined. The precursor product relationship in several metabolic pathways has been investigated by the radioisotopes. Example Krebs cycle, beta oxidation of fatty acids, urea cycle, fatty acid synthesis. 3 is radioisotopes are conveniently used in the study of metabolic pools. Example amino acid pool and metabolic turnovers, protein turnovers. 4. Certain endocrine and immunological studies also depend on the use of radioisotopes, example radioimmunoassay. Fifth is radioisotopes are employed in elucidating drug metabolism. Now let's know about tools of biochemistry. The foundations for the present knowledge of biochemistry are based on the laboratory tools employed for biochemical experimentation. The basic principles of some of the common employed tools now we will discuss. First is chromatography. Chromatography is one of the most useful and popular tools of biochemistry. It is an analytical technique dealing with the separation of related closely related compounds from a mixture. These include proteins, peptides, amino acids, lipids, carbohydrates, vitamins, and drugs. Now let's know about principles and classifications. Chromatography, chroma means color and graphene means to write. Usually consists of a mobile phase and stationary phase. The mobile phase refers to as the mixture of substances to be separated, dissolved, and the liquid or a gas into a into a liquid or a gas. The stationary phase is a porous solid matrix through which the sample contained in the mobile phase percolates. The interaction between the mobile and stationary phases results in the separation of the compounds from the mixture. These interactions include the physiochemical principles such as adsorption, partition, ion exchange, molecular sieving, and affinity. Now, the interaction between stationary phase and the mobile phase is often employed in the classification of chromatography. Example: partition, adsorption, ion exchange, etc. Further, the classification of chromatography is also based either on the nature of the stationary phase, paper thin layer column, or on the nature of both mobile and stationary phases, gas liquid chromatography. Now let's know about partition chromatography. The molecules of a mixture get partitioned between the stationary phase and mobile phase depending on their relative affinity to each one of the phase. Second is adsorption column chromatography. The adsorbents such as silica gel, alumina, charcoal powder, and calcium hydroxy apatite are packed into a column in a glass tube. This serves as a stationary phase. The sample mixture in a solvent is loaded on this column. The individual components get differentially absorbed onto the adsorbent. The illusion is carried out by a buffer system, that means mobile phase. The individual compounds come out of the column at different rate, which may be separately collected and identified. For instance, amino acids can be identified by ninhydrin colorimetric method, an automated column chromatography apparatus. Fraction collector is frequently used nowadays. Third point is high performance liquid chromatography, HPLC, high performance liquid chromatography. In general, the chromatographic techniques are slow and time consuming. The separation can be greatly improved by applying high pressure in the range of 5000 to 10,000 psi pounds per square inch. Hence, this technique is also referred to as high pressure liquid chromatography. For more information on chromatography with special reference to gel filtration chromatography, ion exchange chromatography, affinity chromatography, and hydrophobic interaction chromatography is given under the downstream processing. We will discuss in downstream processing. Now let's know about the electrophoresis. The movement of charged particle in an electric field resulting in their migration towards the opposite charged electrode is known as electrophoresis. Molecules with a net positive charge move towards the negative cathode, while those with the net negative charge migrate towards positive anode. Electrophoresis is a wide used analytical technique for the separation of biological molecules such as plasma proteins, lipoproteins, and immunoglobulins. Different types of electrophoresis. Let's know about the different types of electrophoresis. First is zone electrophoresis. An inert supporting material such as paper or gel are used. Next is second is isoelectric focusing. This technique is primarily based on the immobilization of the molecules at isoelectric pH during electrophoresis. Stable pH gradients are set up covering the pH range to include the isoelectric points of the components in a mixture. Isoelectric focusing can be conveniently used for the purification of proteins. Third is immunoelectrophoresis. This technique involves combination of the principles of electrophoresis and immunological reactions. Immunoelectrophoresis is used for the analysis of complex mixtures of antigens and antibodies. Now let's know about photometry, colorimeter, and spectrophotometer. Photometry broadly deals with the study of the phenomenon of light absorption by molecules in solution. The specificity of a compound to absorb light at a particular wavelength that is monochromatic light, is exploited in the laboratory for quantitative measurements. From the biochemist perspective, photometry forms an important laboratory tool for the accurate estimation of a wide variety of compounds in biological samples. Colorimeter and spectrophotometer are the laboratory instruments used for this purpose. They work on the principles we will now discuss. When a light at a particular wavelength is passed through a solution, that means incident light, some amount of it is absorbed, and therefore the light that comes out, transmitted light, is diminished. The nature of light absorption in a solution is governed by Beer-Lambert's law. Beer's law states that the amount of transmitted light decreases exponentially with an increase in the concentration of observing material. That is, the amount of light absorbed depends on the concentration of the observed molecules. And according to Lambert's law, the transmitted light decreases exponentially with increase in the thickness of the observing molecule. That is, the amount of light absorbed is dependent on the thickness of the medium. The ratio of transmitted light L light L to that of incidence light I 0 L0, this is I0, is referred to as transmitted transmittance, that is T equals to I by I0. Absorbance, in short A, and optical density OD is very commonly used in laboratory. The relation between absorbance and transmittance is expressed by the equation A equals to 2 minus log 10 log 10 T equals to 2 minus log percentage T. Now let's know about colorimeter. Colorimeter or photoelectric colorimeter is the instrument used for the measurement of colored substances. This instrument is operative in the visible range, that is 400 to 800 nanometer of the electromagnetic spectrum of light. The working of colorimeter is based on the principle of Beer-Lambert's law. The colorimeter is in general consists of light source, filter, sample holder, and detector with display meter or digital. The filament lamp usually serves as a light source. The filters allow the passage of a small range of wavelength as incident light. The sample holder is a special glass cuvette with a fixed thickness. The photoelectric selenium cells are the most common detectors used in colorimeter. Now let's know about spectrophotometer. Spectrophotometer primarily differs from colorimeter by covering the ultraviolet region, that is 200 to 400 nanometer of the electromagnetic spectrum. Further, the spectrometer is more sophisticated with several additional devices that ultimately increase the sensitivity of its operation several fold when compared to a colorimeter. The precisely selected wavelength, say 234 nanometer to or 610 nanometer in both ultraviolet and visible range, can be used for measurements. In place of glass cuvettes in colorimeter, quartz cells are used in a spectrophotometer. The spectrophotometer has similar basic component for a colorimeter, and its operation is also based on the Beard-Lambert's law. Now let's know about ultracentrifugation. Ultracentrifugation is an indispensable tool for the isolation of subcellular organelles, proteins, and nucleic acids. In addition, this technique is also employed for the determination of molecular weights of macromolecules. The rate at which the sedimentation occurs in the ultracentrifugation primarily depends on the size and shape of the particles or macromolecules, that is, on the molecular weight. It is expressed in terms of sedimentation coefficient. The sedimentation coefficient has the units of seconds. It was usually expressed in the units of 10 to the power minus 13, which is designated as one Seborg unit. For instance, the sedimentation coefficient of hemoglobin is 4 into 10 to the power 30 minus 13 S or 4S. A ribonuclease is 2 into 10 to the power minus 13 or 2S. Conventionally, the subcellular organelles are often referred to as by their S value, example 70S ribosome. Isolation. Now let's know about the isolation of subcellular organelles by centrifugation. The cells are subjected to disruption by sonication or osmotic shock or by use of homogenizer. This is usually carried out in an isotonic sucrose, that is 0.25 m. The advantage with the sucrose medium is that it does not cause the organelles to swell. The subcellular particles can be separated by differential centrifugation. The most commonly employed laboratory method separates subcellular organelles into three major fractions: nuclear, mitochondrial, and microsomal. When the homogenate is centrifuged at 70 gram for about 10 minutes, the nuclear fraction gets sedimented. On the centrifuging the supernatant I at 15,000 gram for about 5 minute mitochondrial fraction that includes lysosomes and peroxisomes is pelleted. Further centrifugation of the supernatant 2 at 1 lakh gram for about about 60 minutes separates microsomal fraction that includes ribosomes and endoplasmic reticulum. The supernatant 3 then obtained corresponds to the cytosol. The purity of the subcellular fractionation can be checked by the use of marker enzymes. DNA polymerase is the marker enzyme for nuclease, while glutamate dehydrogenase and glucose 6 phosphatase are the markers for mitochondria and ribosomes respectively. Hexokinase is the marker enzyme for cytosol. Now let's know about radioimmunoassay. Radioimmunoassay was developed in 1959 by Solomon Benson and Rosalind Yellow for the estimation of insulin in human serum. This technique has revolutionized the estimation of several compounds in biological fluids that are found in exceedingly low concentration. RIA is a highly sensitive and specific analytical tool. Now let's know about the principle. Radioimmunoassay, in short RIA, combines the principles of radioactivity of isotopes and immunological reactions of antigens and antibody, hence the name. The principle of RIA is primarily based on the competition between the labeled and unlabeled antibody complexes, either labeled or unlabeled. The unlabeled antigen is the substance, say insulin, to be determined. The antibody is to be is it is the antibody to it is produced by the injecting the antigen to a goat or a rabbit. The specific antibody is again subjected to react with unlabeled antigen in the presence of excess amounts of isotopically labeled with known radioactivity. There occurs a competition between the antigen Ag plus and Ag to bind the antibody. Certainly, the labeled Ag plus will have an upper hand due to its excess presence. As the concentration of unlabeled antigen increases, the amount of labeled antigen antibody complex decreases. Thus, the concentration of Ag plus minus Ab is inversely related to the concentration of unlabeled Ag, that is the substance to be determined. This relation is almost linear. A standard curve can be drawn by using different concentration of unlabeled antigen and the same quantities of antibody and labeled antigen. Labeled, the labeled antigen antibody complex is separated by precipitation. The radioactivity of I-131 represents present is Ag plus minus Ab is determined. Now let's know about applications. RIA is no more limited to estimating of hormones and proteins that exhibit antigenic properties by the use of happenes, small molecules such as dinitrophenol, which by themselves are not antigenic. Several substances can be made antigenic to elicit specific antibody responses. In this way, a wide variety of compounds have been brought under the net of RIA estimation. These include peptides, steroid hormones, vitamins, drugs, antibiotics, nucleic acids, structural proteins, and hormone receptor proteins. Radioimmunoassay has tremendous applications in the diagnosis of hormonal disorders, cancers, and therapeutic monitoring of drugs, besides being useful in biomedical research. Now, let's know about enzyme linked immunosorbent assay. Enzyme linked immunosorbent assay, that is in short ELISA, is a non isotopic immunoassay. An enzyme is used as a label in ELISA label in ELISA is in place of radioactive isotope employed in RIA. ELISA is as sensitive as or even more sensitive than RIA. In addition, there is no risk of radiation hazards in ELISA. Now let's know about principle. ELISA is based on the immunochemical principles of antigen-antibody reaction. First point is the antibody against the protein to be determined is fixed on an inert solid such as polystyrene. Second is the biological sample containing the protein to be estimated is applied on the antibody coated surface. 3 is the protein antibody complex is then reacted with a second protein specific antibody to which an enzyme is covalently linked. This enzyme must be easily assayable and produce preferably colored proteins products. Peroxidase amylase and alkaline phosphatase are commonly used. Fourth is after washing the unbound antibody linked enzyme, the enzyme bound to the second antibody complex is assayed. The enzyme activity is determined by its action on the substrate to form a product. This is related to the concentration of the protein being estimated. Now let's know about the applications. ELISA is widely used for the determination of small quantities of proteins, hormones, antigens, antibodies, and other biological substances. The most commonly used pregnancy test for the detection of human chorionic gonadotropin HCG is in urine is based on ELISA. By this test, pregnancy can be detected within few days after conception, and ELISA is also useful for the diagnosis of AIDS. Finally finished. Any questions regarding this you can ask me in the comment box. I will definitely answer the question. Okay, thank you.